Okay, the first thing that we want to do today is another graph, and this is called a box plot. You will have to do a box plot on your first exam, so please write down this information. What a box plot is, it's a 5 summary, so a 5-number summary graph that displays things out of, usually we use it for smaller samples, okay? So it displays quickly 5 things. Those 5 things are the minimum value in your data sets and the maximum value in your data sets. Okay? It also displays the median of your data sets. And then Q1 and Q3. Okay, so these are the 5 things that it displays. And it's called a box plot because the graph of it itself looks like a box. Okay, so let's just do an example. Let me give you some numbers. So let's say here's my data set, X. These are my values. 48, 41, 12, 22. 24, 31. And let's just do a couple more. 39, 35. All right, a relatively small data set here, small sample. So before I want to calculate these, it's probably a good idea to put that list in order, okay? Because you're going to have to find the median, you're going to have to find Q1 and Q3. So the first thing that I would recommend you do is go ahead and put that list in order, sort it from least to greatest, and then we can figure out what these 5 numbers are, okay? So do that, take a second and do that. 12, 22 looks like. 24, 31. 35, 39. 41, 48. How many data values do we have? What's n here? 8. It's an even amount, okay? So is that good or bad for finding a median? It's not the best, right? Because then I have the middle 2 numbers, and I find the average of those 2 numbers. Okay, but in any case, we have 1 and 5 done for us. The minimum here is 12. The maximum here is 48. Go ahead and find the median. So you're going to find the middle 2 numbers. Find the average of those 2 numbers. So let's see. 1, 2, 3, 4, 5. So between 31 and 35. If I add 31 plus 35, hit enter, divide by 2, what do you get? 33. Okay, so my median is 33. All right, and then reminder, when we did this last time, in last class, how do I find the median? And then how do I find Q1 and Q3 after I find the median?
Oh, you do the same thing on both sides.
Right, so the values below the overall median, we're going to take the median of those values, and that will be Q1. So what is Q1 here? 23. Halfway between 22 and 24. And then similarly, we have 35, 39, 41, 48, and that'll mark Q3. 39 plus 41 divided by 2, what do you get? 40. Okay. Are we ready to do the box plots? So these are my numbers, 12, 23, 33, 40, and 48. Let's take a look at what the graph looks like. The first thing that you're going to do is a horizontal axis, And on your horizontal axis, you want to have a nice range of your whole set of values, okay? So my minimum number was 12, and my maximum number was 48, right? So I want to cover all of those values. So what I'm going to do is I'm going to start maybe 10, a little bit less than 12, and I want to finish a little bit higher than 48, so what would be a good finishing point? 50, right? So if I go 10 to 50. And then I just need to make this look pretty, okay? So I'm going to just go by fives. So let's go 10, 15, 20, 25, 30, 35, 40, 45, and 50, okay? And again, it's whatever makes it look pretty. If my minimum was 10 and my maximum was 300, probably not going to go by fives, okay? I'm going to go by a much larger hash mark. Okay? All right, we're going to start with the box part of it. So my Q1 was what?
23.
And my Q3 was what?
40.
Okay, so that is the actual box part of it. So roughly that's 23, roughly that's 40, and you want to make a box with those values. Okay? So this is right at 23, this is right at 40. Q1 is also referred to as the lower hinge, which is the left side of the box. Q3 is also referred to as the upper hinge, which is the right side of the box. Okay? Then you have little things that go out to the minimum value with a dot and the maximum value with a dot. And go ahead and tell your reader what those numbers are. So in this case, it's 48 and 12. And what was my median for this problem?
33.
33. So right where your median is, you just put a vertical line. And that vertical line marks what the median should be. And there you have it. This is our box plot. Okay? So there's 5 things and they're displayed. The lower hinge and the upper hinge of the box is Q1 and Q3. There's a vertical line that represents the median. And then your maximum value is just a dot, and your minimum value is just a dot with a line extending from the box. Okay? It's really quick and easy, and it's called a box plot. Any questions on that? You will have to do one of these on your first test, so just make sure you can do it. Okay? Okay, great. I want to move on today and start probability. Okay, so let's talk about probability. Probability, the definition is pretty much the chance that an event will occur, okay? So our definition here is the chance an event will occur. Okay, so let's define a couple of things. If there's no way in the world, it's impossible that this event can occur, what is our probability for that? What would we say?
0.
0, okay? So probability is 0 if there's no way it's going to happen, okay? It will not happen. What if the event is guaranteed to happen? It's definitely going to happen. What is the probability sign for that? 100% or 1, okay? 1 or 100%. So if it's definitely not going to happen, we say the probability is 0. If it's definitely going to happen, we say the probability is 1 or 100%, okay? And this is important to us because as we start increasing the problem's difficulty and stuff, you're going to have formulas that you're going to use to find probability, all right? But the one thing that we need to make sure we're in line with is the smallest probability is 0, the largest is 1, and it's everything in between, okay? So if you're using a formula and you get your probability is negative 12, you need to think, probably something went wrong, okay? Because the smallest it can be 0, the largest it can be is 1, okay? So if your probability comes out to 200%, again, we probably messed up somewhere, all right? So make sure we're always in line with this, 0 to 1, okay? So any percentage or decimal in between, that's what we're looking for. Okay, we're going to start out with what's called classical probability. And what classical probability does is it uses what's termed sample spaces to determine the probability of an event, okay? So classical probability uses what we call sample spaces. And what a sample space is a systematic listing of every possible outcome. Every possible outcome. Okay? And so how this goes back to classical probability is just a formula that looks like this. So let's say, and here's my notation. The probability that event E occurs, okay, P of E. And we read this, the probability that event E occurs is the number of times E happens in the sample space divided by the total number of outcomes in the sample space. Okay, I'm abbreviating SS for sample space. And that's our definition for classical probability. If you want to find the probability of something happening, you find and list out every possible outcome. You find how many times the event that you're looking at happens in those outcomes, divided by the total number of outcomes. Okay? All right, this is getting crazy theoretical, so let's do some examples, and hopefully it should be more clear. Okay, let's start off with if I roll a single die. Okay? So if you roll a die, what are some things that could happen? You could get a 1, you could get a 2, 3, 4, 5, or 6, right? That's pretty much everything that can happen. Does everybody agree with that? Yeah. So if I roll a single die, how many outcomes are there? There are 6 outcomes, right? You get a 1, a 2, a 3, a 4, a 5, or 6. There we go. That's my sample space. This is everything that can happen. Okay? Now, I'm going to start asking you some questions. If I roll a single die, what's the probability of getting an even number? Okay? How do I calculate that probability? Well, I'm going to use classical probability. Classical probability tells me there's a fraction. The denominator is every possible outcome. How many outcomes were possible? 6. Okay? The numerator is how many times this thing happens in your outcomes. How many times do I get an even number in these 6 outcomes?
3.
1, 2, 3. And that's how we solve this probability. Okay? That's called classical probability. So the probability of getting an even is 3 divided by 6, which I can reduce down to 1/2. And you guys could put 0.5 or 1/2. They mean the same thing. Okay? What is the probability of getting an odd? What would I get there? Yeah, this time it's 1, 3, and 5. It's still 3 out of 6, which again is 1/2. Okay? What's the probability of getting a 2? How many times does that happen out of the 6? Just 1 out of 6. Okay? And I can go on and on and on and make the probability as crazy as I want, right? I could say, oh, what's the probability of getting a 1 or 6 or even? Okay? Now I have to be careful because this problem's weird and I don't want to double count, right? So what's the probability of getting a 1 or a 6 or even?
4.
So you get a 1, you get a 6, or an even. So it throws in the 2 and the 4, right? So a 1, a 6, or an even. Out of the 6 things, 4 out of the 6 that's going to happen. Okay? Any questions on this one? Okay, let's make it a little bit more difficult. I want the sample space for rolling 2 dice. Not just 1, but let's roll 2 dice. Can you do a systematic ordering of listing out the sample space for rolling 2 dice? Okay? Give an example of something that could happen. If I roll 2 dice, what could I get?
A 1 and 1.
1 and a 1, sure. What else?
2.
A 1 and a 2, 1 and a 3, a 2 and a 1, a 4 and a 4, 5 and a 3, a 3 and a 5, 6 and a 6. Okay, but I want to systematically do this. So, 1 and 1, 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6. 2 and 1, 2 and 2, 2 and 3, 2 and 4. Okay, I think you guys recognize the pattern. 3 and 1, 3 and 2. On and on and on. And let's list out every possible outcome. Five and 1, 5 and 2. And finally, home stretch, 6-1, 6-2, 6-3, 6-4, 6-5, 6-6. Okay? If I'm going to use classical probability to solve problems, it's so important that I have the total outcomes listed, right? Because that's the bottom number in my formula. If I get the bottom number wrong, you're going to get everything else wrong. Okay? So get the bottom number right, and we're on our way to getting the problems right. How many others are there? 36 possibilities. Okay? So I'm about to ask you a question. I'm going to say, find the probability of this when you roll 2 dice. Well, you know the denominator is 36. Now it's just how many times does that thing happen in these outcomes listed. Okay? So let's leave these outcomes up and let's solve the first problem. What's the probability of a sum of 6? Question 1. What's the probability of a sum of 6? Okay? Classical probability. List out everything, count how many there are. There's 36 things that can happen. How many, in all of these outcomes, how many times do I get a sum of 6? Where do I get sums of 6?
1 and
5 and 1, 4 and 2, 3 and 3, 2 and 4, 5 and 1. Does everybody agree with that? Are there any other places where I get a sum of 6? So this is it, right? So how many times does that happen? 5.
So 5 and 1 isn't the same as 1 and 5?
They both add up to 6, but this is like a 5 on the, you know, if I had one die in my left hand and one in my right hand, this is my left hand and right hand, this is my left and right, so they're different. Okay? 5 out of 36, and that's my answer. Okay, questions on that? Yes?
If they're different, no, never mind.
Yeah, so when we do a systematic listing, you have to list out every possibility. Okay? All right, question number 2. What's the probability of getting doubles? P of getting doubles. What's the probability of getting doubles? Again, the denominator is 36 because we're still looking at the same probability experiment, rolling 2 dice. How many times do I get doubles? 6 times. Okay, 6 out of 36, we can reduce that, right? That equals what? 1/6. So go ahead and reduce anything that we can reduce. All right, on a quiz or a test, I might ask the question, what has a greater likelihood or chance of happening? Rolling doubles or getting a sum of 6? And what would you say? Doubles. Because you solved it and you did both of the problems, right? It's not a guessing question. Okay. Next question. What's the probability of getting a sum of 7 or 11? Probability a sum of 7 or 11. Getting a little messy here, sorry, but 7 or 11. So this whole corner here, those all add up to 7, right? 1, 2, 3, 4, 5, 6 of them. And 11, we have 2 ways that that can happen. So what's my answer? 8 out of 36. Okay. And again, you can reduce that. 4 goes into both of those, so 2 out of 9. Next question. What's the probability of getting a sum less than or equal to 4? Sum less than or equal to 4. What do you guys think? It's also 6 out of 36, right? It's just this little part here, which is 1/6. So again, on quiz, homework, or something like that, it could say, is the probability of getting doubles the same as the probability of getting a sum less than or equal to 4? Is that true or false? Probability of getting doubles, 1 out of 6. Probability of getting a sum less than or equal to 4, 1 out of 6. It's true. Okay. Okay, next question. What's the probability of a sum of 12? One out of 36. Does everybody agree with that? What's the probability of not getting a sum of 12? 35 out of 36. Does everybody agree with that? My question to you is, how did you get that last answer? What did you do in your head?
Yeah, subtracted.
So this is the probability of getting a 12, right? 1 out of the 36. Probability of not getting a 12. Well, you could be like, that's not a 12, that's not a 12, that's not a 12, and add them all up, but that's not what everybody in the class did, right? Everyone just said, oh, well, there's 36 total, and this only happens once, so subtract from 1, everything else, it's 35, okay? And that's important, because that's a new thing that we want to define, and that's called the complement. Okay? So I'm going to erase my big sample space. And I want to define the complements. There's a couple of ways to define this. If we have E, then the complement, E complement, looks like that. It's just E with a line on top of it. That's the complements. Okay? And what we need to know is the probability of E plus the probability of E complement, which is everything not E, has to equal to 1. Okay? And that's a probability that we're going to make use of all the time. Okay? For example, let's say I say the probability of having our test on Monday is 90%. Okay? So let's say E represents having a test on Monday. And I say the probability of that happening is 0.9. Okay? Then, what's the probability you don't have a test on Monday? 0.10. Does everybody see that? Because this has to add up to 100%. Okay? So the probability of having a test is 90%, then the probability of not having a test is 10%, because it has to add up to 100%. Okay? That is our relationship with the complement. Okay, I want to do another sample space. We're going to roll 3 coins. Maybe roll is not the right word. Maybe flip 3 coins. Okay, give it a shot. Spend a minute or two, see if you can write out every possibility. It's so important that we can do that because that's the bottom number of our denominator. What's one example if I flip 3 coins? What could you get? Heads, right? That should get you started. What else could happen? List them all out. See how many you come up with. Okay? You can list out every single possibility. How many did you get? Hopefully 8. Might spend a few minutes, but hopefully you should get 8. Okay? And again, it's super important because I'm going to ask several questions, and using classical probability formula, the bottom number is going to be 8. Okay? And I need to see that based on listing out everything systematically. Okay, first question. What's the probability of exactly 1 head? So again, what's my denominator? This is every outcome. How many were there? 8. In these outcomes, how many have exactly 1 head? Exactly 1. 1, 2, 3. Right? Exactly 1 head happens 3 out of 8. Okay? We're using the same formula over and over and over. Right? Find how many times that thing happens in the outcomes, divided by the total number of outcomes. Okay? What's the probability of at least 2 tails? What does at least mean? It could be 2 tails, it could be, what else? If at least 2, it could be 2 or more, right? 2 or more. So how many have at least 2 tails? This is at least 2. 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 4 out of 8. Which is 1 half. Okay? What's the probability of no heads? How many times do we get no heads? Just the 1, right? TTT, tails, tails, tails. What's the probability of at least 1 head? How many of these have at least 1 head? 7 out of 8. Okay? One thing that I want you guys to know, because this comes up a lot when we do probability questions, is at least 1 and none are complements. Okay? These are opposites. At least 1 The opposite of at least one, which is one or more, is none. Okay? So please make a note of that in your notes, because that comes up all the time. All right? Any questions on classical probability? So we define classical probability, list out all of the outcomes, count the number, put that as your denominator, find in the event that you're finding the probability for how many times that occurs in your outcomes, that's your top number. Okay? Complement is the opposite of the other thing. Okay? All right.